What is an exponential function? Well, this is what it looks like. I don't think I gave this to you guys yesterday. Did I give this to you guys yesterday?
No.
Okay. Well, this is what an exponential function looks like. It has to have the variable up in the exponent right here. And this a it wouldn't be an a, it'd be a number, an actual number. That's just a placeholder right there, so you guys can copy down a formula. This is the exponential function. That's why it has two e's. Okay, here's the important stuff. A cannot be 0, and it has to be positive. That's why it says a is greater than 0. A cannot equal 1. Hey, why don't I just say a has to be greater than 1? Because there's numbers between 0 and 1 that it can equal. Okay, we can put like 1/2 in for a, but you can't put 1 in there. Why? Because it's not going to change. 1 to the 100th power is still going to be 1. Yeah, it can't be. It has to be positive, and it can't equal 1. And x is any real number, which kind of gives you a hint to what your domains are going to be. So let's look at this one right here. I'm going to call him the parent, or a common function. Didn't we create this table yesterday? Yeah. So I'm going to kind of go a little quick through it. What you do is you pick some x values, and we picked -1, 0, 1, and 2. Actually, it might be a good idea to pick -2 also, just to kind of get an idea of what's happening. And -2 is not that bad to plug in. And then your y. So what do we get when we plug in a -2? Well, to make that -2 a +2, we have to flip the fraction. It now goes on the bottom of a fraction. And then so we find that when we plug in -2, we get 1/9, or 1/9. If we plug in -1, we get 1/3. Which is 1/3. If we plug in 0, it would be 3 to the 0 power. What's anything to the 0 power?
1.
It's 1. Raised to the 1 power would be 3. Raised to the 2 power would be 9. And so when we graph it, it looks like this. -2 goes up to 1/3. I need a different color. Goes up to 1/3. No, -2 goes up to 1/9. Sorry. -1 goes up to 1/3. And then 0 goes up to 1. 1 goes up to 3. And then 2 goes up to 9. That pops up right about there. And so we got our graph like this. I got a challenge for you guys. Give me a number that will make this line dip below the x-axis.
5.
I heard -12, so I'm going to try that. Let's see. -12. If I plug in -12, what do I get? Let's see. 3 to the -12 power. That would be 1/3 to the 12th power. 3 to the 12th power? That's a big number. So that's what we get if we plug in -12. Now, if we have 1 over a big number, is that negative? No, it's not. That just means it's really, really close to the x-axis. And so this would be -11. This would be -12. So my dot would be like super close to the x-axis. And so it doesn't cross over the y, the y equals 0, which is the x-axis. Doesn't cross over that if I have a -12. Well, what if I pick?
3?
What's that?
-3.
-3? -3? -33?
-3.
-3.
Exponent 3.
-3 is not that bad. See, if I go 3 to the -3, that's going to be 1/3 to...
No, I meant 3 with -3 with a positive exponent.
-3 with a positive exponent.
Yeah. A positive odd exponent.
Hold on. You guys are stumping me. Okay, so you didn't mean this, but anyways, this is 1/27, which still doesn't cross the y-axis. What if I said, ooh, come on, -100?
No, it's not going to work.
Why is that not going to work?
Always over 1.
Right, it's always going to be under 1, under +1. In fact, see, this would look like this. 3 to the -100 would be 1/3 to the 100, which is 1 over a really big number.
Let me do it in my head.
Let me do it in my head. So it's a really big number. So it still doesn't cross into the negative zone. And so what do we have right here? We have something that's called an asymptote. You guys see the asymptote? What is this asymptote? How would you define this asymptote? If I said, where is this asymptote? You would say, it is y equals 0. Okay, that's how you describe this asymptote. You say it's y equals 0. So horizontal lines are always y equals, and it crosses through the 0 at the y-axis. Okay, what's my domain?
Oh wait, I have a question. Asymptote is y equals 0.
Yeah, when you ask for a domain, you got to remember, you're always asking, what can I plug into this function? And the answer is, you can plug in anything. You can plug anything into this function, any real number. So you do negative infinity to positive infinity. What's the range? Now here we actually have a limit. Yes?
0.
Yes, it starts at 0 and it goes to what? Positive infinity. Always do a parenthesis around the infinity, but what about the 0? Do I do a bracket or do I do a parenthesis? I do a parenthesis because we'll never actually get to the 0. And so there's my range, there's my domain. So this asymptote is y equals 0 because there's nothing adding to the 3 to the x power. Very nicely said. So if this number is changed, then that would change my asymptote. My asymptote would no longer be y equals 0, it would be y equals 5. But I'm going to get to that. Okay, so we're going to keep this guy right here as our parent, as our common function. That way we can see how the function shifts. And so I give you guys some graphs that already have this graph on there for you. That is 3 to the x power. And so now let's graph the child, which is this guy right here, so that we can see what this plus 2 does. Now most of you guys already know right now. What is that plus 2 going to do? It's going to shift it up, okay? But I like to be very thorough, so make sure you guys all are getting it. So we have x, and we plug in -1, 0, 1, and 2, and we're good because when I plug in -1, I'm going to get, 3 to the -1, and I have to add 2 to it. 3 to the -1 is 1/3, and I have to add 2 to that, so that's 2 to the 1/3 power. If I put a 0 in there, I get 3 to the 0 power plus 2, which is going to be 1 plus 2. Hey, look, 1 plus 2. And I get 3. 3 plus 2 is 5, and 9 plus 2 is 11. We made these tables yesterday. You guys remember? Now, if I actually graph these, I go -1, 2, 2 and 1/3. See, 2 is right here, and so I go 2 and 1/3, which is about right there. 0 goes up to 3, and 1 goes up to 5. And then 2 goes up to 11, which is kind of off my graph right there. So my graph would actually look like this. That's actually pretty good. There's my asymptote. That's the line it will never cross. And so how would I define that?
Y equals 2.
Y equals dose, because it moved up 2. It shifted up. If it shifts down or up, if the exponential function shifts down or up, then that changes your asymptote. Man, I have like 2 videos like this. It's not good. Okay, so the domain doesn't change. It's still going to be negative infinity to positive infinity. The range does change. What's the lowest that the numbers can get to?
2.
It'll never actually get to 2, but that's our bound, right? And then it goes to positive infinity, and we put parentheses around both of those. All right, let's look and see what happens when we do this. Here's another child. In this child, we put a negative in front of the 3. How does that change? How does that change our common function right here? This is our common function. What does it do?
Y is negative.
Yeah. Oh wait, what does it switch? The x's or the y's?
The Y.
It switches the y's, and here you can test it to see if that's true. If I plug in -1, 0, 1, and 2, what would I get? Well, if I plug in -1, it would be -3 raised to -1. What does that -1 see? Does it see the exponent or the negative sign right here? No, it doesn't. So it's like there's parentheses around the 3, and so you take the negative, and then you have to flip this, so you get 1 over 3, so it's just -1/3. If I do the next one with a 0, let's see, -3 raised to the 0 power. The 0 only sees the 3, right? Okay, so it's -1. If the parentheses were around the whole thing, then this would be a positive one. Okay, but there's no parentheses around the negative and the 3. And plus, that can't be true, because remember, a has to be greater than 0, and here a is not greater than 0 for an exponential function. I said that in the first slide. Okay, so all the rest of them is just going to be the same thing, but it's going to be negative. So we have -3 and -9. When we graph it, let's see how different it looks. -1 we go, oops, I forgot my negative on the 1/3. -1 we go down to -1/3. For 0 we go down to -1. For 1 we go down to -3, and for 2 we go down to -9. And our graph looks something like this. I really should be plugging in -2 to see what. Should have 5 points. Okay, let's do it. -2. If I plug in -2, it would be -3 to the -2. That would be -1 over 3 squared, which would be 1 over 9. So at 2, negative 2, we go, boom. It's still on the line. Sweet. So what does a negative do when it's in front of it like that?
Flex it on the x-axis.
It flips it according to the x-axis. Right? It went from top to bottom. Okay? It flips it according to the x-axis. Now, does that change my asymptote? No. The asymptote's still the same, except this time it kind of has a different role in finding the range. Okay, so the asymptote is still y equals 0. What's my range?
Negative.
Negative infinity to 0. So the 0 switched to a different spot. Domain is still negative infinity to positive infinity. Now we're going to do part 2, or a different video for the next one, just because this video is getting too long. Now, so far what we've done is we've made changes to the y's. We put a negative on the 3, and we've added something. I mean, you could also subtract something, but we've added something to the function to change the way the graph looks.